Hello dear class 10 students, I hope everyone is doing well. So welcome to lecture number 3 of the chapter Metals and Non-Metals. So guys, in this module, we will continue the remaining physical properties of metals and non-metals. So here we will see the thermal conductivity, electrical conductivity, sonority and a comparison between metals and non-metals. Alright, now let us see the thermal conductivity. Can you hold a hot metallic pan which is without a plastic or a wooden handle? Now consider a hot metallic pan without having a plastic or a wooden handle. So will you be able to hold it? Perhaps not. Metals are good conductors of heat. So definitely you cannot hold a hot metallic pan because metals, they are good conductors of heat. So even if you try to hold the hot metallic pan, your fingers might burn. Metals are used for making cooking utensils. Now as you can see here, essentially these metals, they are used for making cooking utensils. Clear everyone? Silver is the best conductor of heat, followed by copper. Now silver, it is the best conductor of heat, which is followed by copper. Non-metals are generally poor conductors of heat. Now we came to know that metals, they are good conductors of heat, whereas non-metals, they are generally poor conductors of heat. Now next we will see the electrical conductivity. So let us do an activity. Now the aim of the activity is to show that metals and graphite are good conductors of electricity and other non-metals are poor conductors. So we will perform an activity where we will show that the metals and graphite, they are good conductors of electricity, whereas other non-metals, they are poor conductors. So remember that this graphite, it is also a non-metal. Alright, now set up the apparatus as shown in the figure. Clear everyone? Now as you can see here, this is a pencil cell and this is a bulb of 1.5 volt. And these are the two copper wire of ends A and B. Now connect the two free ends A and B of the copper wire to a iron nail. Now we have to connect the two free ends A and B of the copper wire to this iron nail. Okay, so after connecting it, we can see that the light bulb, it glows. Okay, now next connect the two free ends A and B of the copper wire to a graphite rod. Now replacing the iron nail, we have to connect the two free ends A and B of the copper wire with this graphite rod. So similarly we can see that the light bulb, it glows. Okay, now next connect the two free ends A and B of the copper wire to a circle. Now replace the graphite rod with a circle. So here you can see that the light bulb, it doesn't glow. So what we have observed, the bulb glows when metals and graphite are connected to the free ends of the copper wire, but not for other non-metals. So from here we have observed that the bulb, it glows when metals and graphite, they are connected to the free ends of these two copper wire, but not for the other non-metals. So essentially this piece of circle, it is a non-metal. So thus the bulb, it doesn't glow, because we can say that, or we can conclude that the metals and graphite are good conductors of electricity, whereas non-metals are poor conductors. So from here we can conclude that the metals and graphite, even though the graphite, it is a non-metal, but they are good conductors of electricity. That means electricity can pass through them, whereas non-metals, they are poor conductors. That means electricity cannot pass through them. Clear everyone? Alright, now let us see the another physical property of metal and non-metal, that is sonority. When metal pipes strike each other, they produce a ringing sound. Now if you have observed, then you might have heard that when the metal pieces, they strike with each other, then they produce a ringing sound. Have you heard of it? Most probably yes. The property by virtue of which metal objects produce a ringing sound when struck with a hard object is called sonority. Now basically sonority, it is a property by virtue of which any metal objects they produce a ringing sound when they are being struck with each other with a hard object. Okay, so that property is called a sonority. Clear everyone? So objects like wind chimes and bells make use of this property of metals. Now this sonority, they have, so objects like wind chimes and bells, they have the property of sonority because they make us noise when they are being struck with a hard object. Alright. Non-metals produce a dull sound when struck with a hard object. So we got to know that metals, they have the property of sonority, whereas non-metals, they produce a dull sound. That means they do not have the property of sonority. So when non-metals, they struck with a hard object, they produce a dull sound and they do not have the property of sonority. Clear everyone? Now let us distinguish between metals and non-metals. Alright, now let us see here. So guys, metals, they have the property of luster, whereas non-metals, they do not have the property of luster. Now metals, we know that they can be polished and thus they have a shiny surface, whereas non-metals, their surface is dull because non-metals, they cannot be polished. Metals are malleable, non-metals are not malleable. So metals, they have the property of malleability. That means metals, they can be beaten into thin sheets or foil, whereas non-metals, they do not have the property of malleability because they are brittle and thus they cannot be beaten into thin sheets or foil. Metals are ductile, non-metals are not ductile. Now metals, they have the property of ductility, whereas non-metals, they do not have the property of ductility. Now in case of metals, they can be made free to thin wires, whereas non-metals, since they do not have the property of ductility, thus they cannot be changed into thin wires. Metals are good conductors of heat and electricity. So basically the metals, they are good conductors of both heat and electricity. Non-metals are poor conductors of heat and electricity, but non-metals, they are poor conductors of both heat and electricity. Alright. At normal temperature, metals are in the solid state. Exception, mercury. So at room temperature or at normal temperature, the metals, they are in the solid state. But there is an exception, so which we have already studied in our previous lecture. So the exception is mercury. So mercury, even though it is a metal, but it exists in liquid state at room temperature or at normal temperature. Whereas in non-metals, at normal temperature, non-metals are in the solid or gaseous state, exception bromine. Now at room temperature or at normal temperature, the non-metals, they are in either solid or gaseous state. But here is also there is an exception. The exception is bromine. So basically what happens, the non-metals, they exist in the solid or gaseous state, right? But this bromine, it exists in liquid state at room temperature. So being a non-metal, it exists in a liquid state at normal temperature. So guys, as I already told you that these exceptions are very important, so you just need to remember it. Alright. Ordinarily, metals have high densities. Ordinarily, non-metals have low densities. Now if we talk about the density, then metals, they have high densities. Alright. Whereas non-metals, they have low densities. Metals are sonorous, whereas non-metals are non-sonorous. Now metals, they have the property of sonority, whereas non-metals, they do not have the property of sonority. That means metals, they make sound when they are being struck with each other or with any hard surface. So they make a ringing sound. Whereas non-metals, they make a dull sound when they are being struck with a hard object. Clear everyone? Okay. Now let us see a few questions. Write the differences between metals and non-metals on the basis of their physical properties. So guys, we have already discussed the differences between metals and non-metals on the basis of their physical properties in our previous slide. Well, I'm showing you again. So this is an important table where the differences between metals and non-metals on the basis of their physical quantities. So try to understand and remember it. Alright. Now let us see the second question. Why cannot you have wooden bells? So can you guys now tell me why we cannot use the wooden bells? Yes, definitely because of the property of sonority. Now we know that wood, which is a non-metal, and non-metals, they do not have the property of sonority. So this is the reason why we do not have wooden bells. Because if we have wooden bells, then we know that non-metals, they make dull noise when they are being struck with each other or they are being struck with a hard object. Whereas non-metals, we use metallic bells because they have the property of sonority, because it produces the ringing sound when it is being struck with each other or being struck with any hard object. So this is why we do not use wooden bells and instead we use some other metallic bells, because the metallic bells, they ring, whereas wooden bells, they do not ring. Alright. Now let us see the third question. Non-metals do not conduct heat or electricity except one. Name of the non-metal. Okay guys, now there is an exception. Non-metals, we know that they do not conduct heat or electricity, right? But there is an exception. So the exception is graphite. So the graphite, it is a good conductor of heat as well as it is a good conductor of electricity. Alright guys, so we have completed the physical properties of metals and non-metals. Thank you guys and keep on studying.